Alright mate, today you're going to be talking to yourself about descriptives. And this is the first thing that you learnt in statistics. It's really pretty basic. So, what is statistics? One, it is the designing of studies and analysing data. Yeah? Now, what is data? It's anything measurable. Now, statistics attempts to distinguish systemic patterns over chance variability. So if you flip a coin 50 times, say 100 times, and you get anything other than 50-50, chances are it's just chance variability or the coin is biased. We'll talk a little bit more about that later. Now, the point is to monitor the cause and effect of variability. So, for example, with natural disasters, with car crashes, with life insurance, things that you're going to be dealing with as an actuary, there are a bunch of things that happen and you have to determine their probability before they do, and thus their outcome. Now, in statistics, there is a sample and there is a population. Yeah, the population is the entire set of people that you are trying to get information from. Now, if you take survey of the entire population, it's called a census. That's really impractical. So you would then use a sample. Now, the whole point of the sample is to have a smaller portion of the population that is realistic to survey, and thus you can make inferences. Now, the people that make up your sample, they're called experimental units. That's a noun. Units. For example, in the example of the coin, it will be the coin. Now, your experimental units have variables. This is the thing that you measure. So, all coins, one particular coin, heads or tails, yeah. A number of heads and tails. Now, there are some key terms that you're going to have to know as a B-grade statistician. Number one is parameters. Now, these are the values which characterize a population. Yeah? The entire population of people are between half a meter tall and 2 meters tall. These are denoted by Greek letters such as this one, which means for standard deviation, and mu, which is the mean. Then statistics are the characteristics of a sample. Okay, these are denoted by Roman letters, such as x bar, which is the mean, and s, which is standard deviation. Again, in the example of tossing a coin, the proportion of heads in a population, or pi, should be 1/2. In a sample, the value can differ. For example, 1.4 in 10 tosses, 4 heads is a fairly normal measurement because your sample size is still too small. Pi is the chance in a population, probability. This distinction is called sampling variability. If you don't know what pi is, we develop a model for predicting what it might be, and that model is based around this. Again, statistics is using this to infer about this. For example, 6 out of 10 heads is okay. However, 60,000 out of 100,000 heads probably indicates bias because your sample size is much larger. Now, there are a couple of different types of data. Yeah? They are categorical data or qualitative, or numerical data. Now, in categorical, different color there. In categorical, there is nominal and ordinal. In nominal, the order doesn't matter. Okay? For example, color and gender. There is no order to the pens that I'm using. There is no order to, the gender of people. You just take it. Ordinal, there is no linear scale. However, there is a ranking system, per se. For example, first, second, third, etc. is actually ordinal data. Okay? Yes, it has numbers in it, and there will be categories labeled as numbers. However, the numbers don't actually mean anything from a measurement perspective. You can also include a range of numbers. So if you say your salary goes from 100 to 200, that is considered ordinal data. Okay? Now the second type of data is numerical. Yeah, or quantitative. Qual, quant. Now, there's discrete, which means it's countable. There is a finite set of increments in all possible values. Usually this is just natural numbers. Okay? Count. Then there is continuous. These are things like temperature, where there is an infinite number of subdivisions within the possible measurements. So temperature, it cannot be 1 or 2. It can be 1, it can be 2, it can be 1.5, it can be 1 point recurring 7. It can be an infinite number of subdivisions within the thing, within the 2 points. For example, height. An example for this is number of traffic accidents. Now, when it comes to measuring data, when it comes to using what you learn here with the different analysis to draw conclusions about your main population, you need to find the typical outcome, okay? This is the most important thing that you're looking for. Now there's two kinds. There is the mean, and there is the median. These are denoted by X bar in the sample, or X squiggly line, whatever that accent's called. And in the population, they are denoted by mu bar and mu squiggly line. Another thing you need to find that's important is the standard deviation. So, when you talk about height, you say that 70 centimeters is the average height, give or take 5 centimeters. 250 centimeters would be too far off. Give or take 100 centimeters would be too far a range, too large a range. Alright, so the subscripts of a series denote their individual values. Right? So the first value of the first measurement of variables that you take is x1, then x2, etc. Right? Now the average is the sum of I is equal to, make that I is equal to 1, then I is equal to n, where n is the last number in your sample. Take that sum, you're going to divide it by n, and it's, so the sum of each of the, why am I explaining this to you? You know what an average is. Yeah. Alright. Mean is the best possible indication of value, except in the instance of outliers or multimodal results. It is, however, good for a wide range of possible outcomes. So if you have a Gaussian bell curve that looks like this, and these aren't wrong, then the mean will take into account the entire spectrum, which is quite important. There is also the trimmed mean, which simply gets rid of this and only takes the average of what's here. Now this is quite important. The median can be referred to as the trimmed mean, where P, which is the percentage that you cut, is equal to 50, because it is the middlemost point. Yeah? It's the data entry such that half of the values lie above and half lie below. Now, if n is odd, then mu squiggly line is approximately equal to x squiggly line, which is equal to x over n plus 1 over 2. If n is even, then mu squiggly line, which is approximately equal to x squiggly line, is equal to x over n over 2 plus x n over 2 plus 1, all divided by 2. Basically, this means that in an odd sample, you take the middlemost number, and in an even sample, you take the two middle numbers and you find what's between the two. Now, median is good for a skewed sample. Okay? Say there are 5 entries here and only 2 on this side, the median will find the value that's about here. This disregards the excessive number of entries here, which would skew the mean, and helps you find a more typical entry.